Hey, good afternoon, everyone. Trackman 44 here. One thing we're doing this total duct renovation. You know, new air conditioner, new air handler, the whole ball of wax. But one of the things we're doing is we're adding a forced air wood furnace to the system. You got to stop and think. Well, how do you want to do that in a safe manner? The rule of thumb is, and what you have to remember is that you always, if you have any kind of dampers that are going to be automatic, electrically operated, which this one is going to have, you got to remember that on a power failure, the dampers have to be installed in such a manner so that they spring return to the open position or remain in the open position during a power failure. Reason being, say it's a nice cold winter day and you just got a rip-roaring fire, just got her built up and she's just taking off like crazy, and you lose power. If you have your dampers wired wrong or your setup installed incorrectly, your dampers on a power failure can go close to your wood-fired appliance, and if they go close to the wood-fired appliance, you're going to tremendously overheat the combustion chamber, overheat the heat exchanger, can overheat your ductwork, and you can literally get it so hot that you can just pull the resin out of the yellow pine floor joist. So you got to be really, really careful how you do this. You always want to make sure that you install the dampers and wire them, control them in the manner in which on a power failure the dampers will fail open to the wood-fired furnace position. Doesn't matter if they're closed in the electric furnace or the gas furnace, you don't have power anyway to get any kind of heat out of either one of those. The only one you're going to be able to get heat out of is the radiant heat out of your wood furnace that now is unable to operate because you have no electricity. So the dampers have to fail in the open position. Enough said. So we're going to make a set of dampers for the plenum on the electric furnace that's going to act as a backdraft damper whenever the wood furnace is in. In other words, when the wood furnace is blowing into the fitting, it's going to go into the main trunk line. We want that to pressurize the main trunk line and not blow backwards down through the electric furnace or the gas furnace, because the supply air temperature off the wood furnace can't actually blow into it without a damper, and it can actually cycle the heat sequencer's thermal limits. It can get so hot that it'll cycle those thermal limits, and if you cycle them enough, you're going to burn them out. Or you can actually open up the limit switch on the gas-fired furnaces. So you have to make sure that doesn't happen. So the way you do that is put a set of mechanical dampers, whether they're manually operated or electrically operated, in the plenum or the discharge airstream of the electric furnace. Conversely, then you have to have that same set of dampers in the supply air of the wood furnace, but we're not going to go there yet. We're going to solve this issue first. So that's what we're going to do today. A really crude drawing here. You can see just kind of a square box, only 6 inches tall, 20 inches wide. That's the width of the electric air handler, 16.5 inches deep. And you can see these funny looking marks right here. I didn't draw them all the way across because it'd be too confusing, but those signify a 4-piece damper that's going to be connected via linkages and an actuator that's going to roll them open and close, and they're going to interlock at the edge of each one so that the only leakage we have is going to be around the perimeter. We can't make them so tight that there is virtually no leakage, simply because they'll just scrape along the sides of the trunk line and they're going to make noises. A little bit of leakage is not bad. Excessive amount of leakages is not good. So it's going to be a minimum amount of leakage around the perimeter of the set of dampers. Now, I've showed 4 dampers in there because 3 would make the dampers individually too large. 5 is just going to make it so much more complicated and much more difficult. 4 is going to be a good dimension because we have a 20-inch width right here, and 20 divided by 4 is 5. So if we want to end up with 5-inch dampers, by the time we put the reinforcements and the interlocking edges on them, they're going to shrink. So we're going to start off with about 5 7/8 inch, roughly 5 7/8 to 6 inch wide planks of metal. And we're going to use 4 of them. Or what I like to do is you have to mark 1 inch and 1/2 inch and 1/2 inch and 1 inch on either side of this. So what we'll do is we'll go ahead and put 1 inch on this side. The opposing side gets 1/2 inch. We turn this over, we get 1/2 inch on the opposite side of the 1 inch, and over here we get the 1 inch on the opposing side of the 1/2 inch. So now we have 1 inch, 1/2 inch, 1/2 inch, 1 inch. Now we got to trim these corners off. Of course, we got to make 4 of them. We're going to trim these corners off just like this, right here at the 1 inch mark. At the same time, we want to measure and mark us a dead center line right down through the center, because it's easier to locate that dead center right now than it will be after it's folded up. This measures 5 7/8 inches, so half of 5 7/8 is 2.5 plus 7/16, so 8 7 is 15, so that's 2 15/16. That'll come into play later on, not right now. I'm just going to go fold it and bring it back. What we're going to do is we're going to bring this 1/2 inch in 45 degrees. Easiest way to make these is go to your 1 inch mark and bring up a 45. Then flip it over, go right straight into all the way into the hilt on this guy right here, and bring it up to a 45 up here. So let's do that again. Bring the 1 inch to a 45 here, turn it over, and then bring it to a 45 all the way up there. With the second one, now you can kind of get a rough idea. See the interlocking? It goes like this. They'll interlock. So here's your 4 right here. The good thing about this, you can use scrap metal. If you see there's odd cross breaks and stuff in these two over here, it's just scrap metal, used material. Now you can adjust this a little bit, this and that. It just has to interlock to block the airflow. It doesn't have to be absolutely perfect. And if you're lucky, the first try you'll get the full dimension of what you want to cover. In my case, which is 20 inches, and I'm at 19 7/8 inches, so I'm very, very close. If you're a little bit wide, you can just take every one of them and just squeeze those angles up just a little bit to shorten the overall dimension. Or if you're a little bit narrow, you can actually flatten out and just kind of spread it just a little bit in order to fill the whole area. I had to cut 4 of these shafts down. Here's 2 of them already mounted. This is going to be number 3 mounted here. And these are all the same length, except for there has to be one that drives them. And so this one here is much longer. You can see it's several, or maybe 1.5 inches, 2 inches longer than what the other 3 are. Because this is a very critical component, this is on a wood-fired appliance, you have to make sure that there's nothing you're doing that can cause or create an issue in the future. So to make sure that these bolts cannot back off, I like to brad them, and I've done this many, many times. Not only tightens them up tighter than what you had them before, but it also ensures that they cannot possibly, through vibration, back off, create a blockage in the ductwork that'll cause anything to overheat as a result of this failure. So it's always something to bear in mind. Always err on the side of safety when it comes to wood-fired appliances. And now you're seeing the importance of having the center line marked on those before we folded them up, simply because now I've got the scribe mark there, I've got the holes drilled in here and the spacing that I want. All I have to do is look down through here and then line this up until I see the scribe mark, hold it in place, and mark my holes, then drill my holes. Without those, you have to do all your measuring again. For reasons we're going to experience on installation, the damper assembly itself is going to be housed in a horseshoe-shaped 2-piece plenum. And by that I mean we're going to build a 16 1/4 by 20 by 16 1/4 3-sided plenum that's going to look like that. It's just a horseshoe. Now we're going to have a Pittsburgh lock on the front of this one and a Pittsburgh lock on the front of this one right here. So the 4 damper assemblies will literally assemble in back here, and they'll be laying horizontally until, of course, they rotate. That whole assembly will be S and drive connected into the main supply trunk, or the bonnet, so to speak. That whole assembly will be there. Then we take this one piece across the front, cut the matching 4 holes for the damper linkages and rods to stick out the front, and then that'll assemble right across the front. Then we'll have a 2-piece damper housing that'll easily install in the trunk line right under the T and above the plenum off of the furnace. I hope that makes sense to you. The dimension is going to be 16 1/4 by 20 by 16 1/4. So the cut size is going to be 16 1/4 plus 16 1/4, 32 1/2, plus 20, which is 52 1/2, plus the 2 Pittsburghs, which is 54 1/2. So what we'll do is we'll go ahead and mark with our scribe up on a metal at minimum of 6 inches, and we'll go down this way a minimum of 54 inches, and we can go ahead and lay out the width, which we know is going to be 6 inches because we've We measured that on the job site, so that's just simply going to be 6 inches. We've already got our 1 inch marked right here for the Pittsburgh, so I'm going to go off of there 16 1/4 inches. So that's 17 1/4 from the outside edge, but 16 1/4 inches. Then we need a 20th for the width. Another 16 1/4, and then the 1 inch for the Pittsburgh. There's our 16 1/4. Here's our 20, our 16 1/4, and our 1 inch for the Pittsburgh. Trim this out. No cross breaks on this little guy right here. A cleat folder is not the easiest tool for people that are unfamiliar with it to get used to. But once you get used to them, they're really great. This particular one is limited to 18 1/2 inches. The trick on them is don't smash the drive all the way over completely flat. You want to leave it a little bit of clearance in there, so it's easy to slide your drive in on a job site. When you smash them down too tight, it's time consuming on site to try to open them back up again. I bought this drill for $7 in a pawn shop in Wisconsin. In Wisconsin Dells. Now I got to make this front part up here. We just need the cut size to be the width of the duct, which is 20 inch, plus 1/4 plus 1/4, by the height, which is 6 inch. So you just go ahead and take your scribe and mark your 1 inch. Mark your 1/4, mark your 1 inch, mark your 1/4, and go ahead and trim. Now we're going to mark our holes the same distance what we marked on the other side. We want these to be fairly accurate. So now that we've got to start on the full assembly, I've got to go ahead and make the fitting that goes underneath this to kind of give a little more stability to it, so I can actually work on the final adjustments on making all this stuff function the way it needs to. What we have to have on the top of a small plenum box on the discharge of the air handler is going to be an equal taper 4-way transition, 16 by 10 1/2 to 20 by 16 1/2. So I got this marked at 24 inch, and I also put me a center line mark at 12 inches. So off of that 12 inches, we need to come out here and get the 20 inch dimension. So that's going to be 10 inches off the center right here. So we're going to get a 10 inch mark over here. And we'll do the same thing, get us a 10 inch mark over here. All right. And then off of that center dimension, because it's the 16 inch down at the bottom, we're going to go 8 inches off of that center line right there. We're going to get us a mark here. And we're going to go 8 inches off of this center line. And we're going to get us a mark over here. We're going to connect those dots now. We're running for a raw edge height of 10 inches. So our actual height, we mark 1 inch down off of that for our S or our drive connection, whichever one it may be. Then at the angle that we marked the actual transition going this way, we'll go ahead and get us a 1 inch mark out there. Mark our lock former or our Pittsburgh line. Same thing over here. Put us a 1 inch mark over here. We know it's going to be 1 inch all the way around, so we'll go ahead and mark our 1 inch scribe. There's our lock former corner, or edge. That's the S and drive. And back again for the lock former. We'll go ahead and trim those guys out. So now what we do, we measure the length of the sides, and you have to visualize exactly where that corner is before it makes that 1 inch going up. And this particular one here is going to measure at 8 1/4. So you have an 8 1/4 actual length plus 1, so the cut size on this end is going to be 10 1/4. This one here's, it's an equal taper. You can double check the measurement, but this is also going to be 10 1/4. 8 1/4 actual plus 1. Now the transition is going to be an equal taper, and it changes in size on that dimension, on the opposing dimension, from a mere 10 1/2 inches down here to 16 inches up here. So that's why this cocks out that way right here. So what we have to do is, we know now we need to have 10 1/4 inches, and we have to start off with it down here at 10 1/2 and spread out to 16 at the top. So I went ahead and made the cut. I got the 1 inch for the drives and the S's marked, and I've got a center line. I'm going to go ahead and highlight that center line, and we're going to start off with 10 1/2 inches. So 10 1/2 inches is 5 1/4. So if we go 5 1/4 inches out from here, and 5 1/4 inches out from here, and we're going to 16, so we go up here and we go 8 inches out from the center, again marking on the 1 inch line, 8 inches out from center, and we connect those dots. I'll highlight them with a magic marker in a second. There's our layout. It'll be exactly the same on both sides. Now, at the angle that this is, you add the 1/4 inch to go into the Pittsburgh. 1/4 inch, 1/4 inch. This will be the layout for the sides. Going to go ahead and cut that, trim this, use this as a pattern, lay out the second one. Now we'll fold these, and also it has to bend out and bend back too. We'll put a slight, very slight cross break in this just for stability. Get our 1/4 inch. Now this has to go out and then flare back in. We'll go ahead and put the flare in part. Just a little bit. This is adjustable. But the flare out, if we put the flare out in here, because the 1/4 inch bends, it's going to smash the bends over. So we're going to do those by hand. I'll show you that. All we do to flare it out is go ahead and grab an S and just put a bit of a crack on it. Again, these are all field adjustable. Whenever I assemble the fitting here in a few minutes, we'll have to adjust those angles just a little bit. Looks about right. We're supposed to be 16 here at the top. We're 16. Supposed to be 10 1/2 down here. We're 10 1/2. We're supposed to be 20 up here at the top. We're 20, and we're supposed to be 16 down here at the bottom. And we're dead nut on 16. The total height is supposed to be about 9 1/2 inches, thereabouts. And we're 9 5/8 inches. Now we can go ahead and mount our damper assembly on top of here and have a nice sturdier base in order to get all the linkages and stuff worked over on that damper assembly. Now if we get really lucky, this 4-way equal transition is going to go ahead and mount directly to this damper box. Something like that. Now that's upside down. This is the actual way it's going to go right here. So I need this on here to be stable so I can go ahead and start working with all of this stuff up here. Now, because this is time consuming and somewhat tedious to get these adjusted on here, I didn't even bother putting them on film because it did take a lot of tinkering and fiddling just to get them to operate this good. So I have to do some adjusting before I start searching for an old used actuator. It'd be an actuator something similar to this right here, and you can see the square drive on that. It'll go on this way or that way depending which way you want it to rotate, and it'll actually clamp right onto here, and then it'll secure it to your ductwork, and then this will go ahead and rotate it. And what I want are ones that rotate then spring return. Whenever the situation needs to be reversed, they will spring return. This here again is dampers that go on the supplier plenum of the electric furnace. So these need to fail to the closed position if the house loses power. I'll explain all that when we get around to the installation. But at any rate, if you just take a look here, you can see here's the 4 rods that are connected to the 4 dampers, and the actuator is going to go ahead and turn these guys this direction here. You can see the dampers open up, and it'll go ahead and reverse and go back this way like that right there. Like I say, these are not completely done yet, so bear with me. There's your open position right here. They're going to allow the airflow directly up into the main trunk line. Then the actuator will reverse position, close the dampers. Now the backdraft off of the wood furnace blowing into the trunk line will stop and not blow down into the electric furnace. I hope you all enjoyed that, but it takes a little bit of time to do these things. There still is some more adjusting to do. So you know what? I think we beat this one to death. So this is Tractorman 44, and I'm out of here, guys.